All right, let's dive right in. Today, we're talking about a revolution that's happening as we speak. It's where three powerhouse technologies, we're talking robotics, AI, and VR, are smashing together to create something fundamentally new. We're calling it physical AI.
And that really brings us to the central question, doesn't it? What actually happens when AI gets a body? We're moving way beyond AI that just sits in a cloud and thinks. We're talking about AI that can see, learn, and physically act in our world.
So, to really get your head around physical AI, the best way to think about it is, well, it's kind of like a human body. It's built on three really distinct but totally interconnected layers.
Okay, so first up, you've got the brain. This is the artificial intelligence layer. This is what does all the heavy lifting, all the thinking, seeing the world through its sensors, figuring out its next move, and making those crucial decisions all by itself. Next, you need a body, and that's the robotics layer. These are the physical parts. The industrial arms on an assembly line, the rovers exploring a new terrain, those incredibly precise surgical tools, they're the parts that actually reach out and touch the world. And finally, you need the senses. This is where virtual reality comes in, and it's a total game changer. It creates this immersive bridge that lets a person see, hear, and sometimes even feel exactly what the robot is experiencing. It's the link between our mind and the machine.
So when you put it all together, this thinking brain, this physical body, and these immersive senses, bam! You get physical AI, a system that can genuinely and intelligently operate in the real world.
Okay, but for this whole thing to work, especially when you're controlling it from miles away, there's one thing that is absolutely critical: speed. The single biggest roadblock right now is something called latency. It's that tiny delay between when you give a command and when the robot actually moves. And this number right here, this is everything. For something as high stakes as remote surgery, that delay has to be under 200 milliseconds. We're talking less than a quarter of a second. If it's any higher than that, performance just drops off a cliff. It becomes clumsy, difficult, and frankly, dangerous. So, how do we fix it? Well, check this out. The old way meant sending data all the way to some distant cloud server and then waiting for it to come back. That's what causes the delay. The solution is Edge AI, and it's actually a pretty simple idea. Just move the brain, the computer, right next to the robot's body. By doing that, you slash that round-trip delay by a staggering 86%. It makes real-time control not just possible, but a reality.
All right, so we've solved the speed problem, but now we hit the next big wall: data. I mean, to train an AI to handle all the crazy, unpredictable stuff in the real world, you need a mind-boggling amount of experience. Way more than you could ever get by just using physical robots. It's just not practical.
And this is where it gets really cool. We use what's sometimes called the Industrial Metaverse. The process is genius. First, a human expert just hops into VR and shows the robot how to do a task. Then, generative AI takes that one example and cooks up millions of different virtual scenarios for the AI to practice in, all completely safe, no risk of breaking anything. After millions and millions of tries in this virtual playground, the AI is finally ready for the real world. So we've covered the how, which is fascinating. But what about the so what? What can this tech actually do? Let's look at the real-world impact it's already having, because the results are, well, they're incredible. I mean, just look at these numbers. They really speak for themselves. In manufacturing, when you use VR or XR for things like quality control, you see an 86% drop in errors. And AI doing visual inspections can be up to 5 times more efficient than a human. And in healthcare, surgeons who train in VR are nearly twice as likely to pass their final assessments. These are massive gains. In this chart, this really nails a critical point about safety. You might think a keyboard and mouse are fine, but in really complex, high-risk situations, they lead to way more accidents, more collisions. But because a VR interface is so intuitive and gives you that sense of space, you see significantly fewer errors. It's just demonstrably safer. Of course, you can't have a technology this big, this transformative, without talking about what it means for us, for society. It's not just about the tech, it's about the human impact. And we are facing some huge questions. Who's on the hook when an autonomous robot gets it wrong? How do we build these things so that they're fair and we can trust them? And then there's the big one. An estimated 1.1 billion jobs are going to be transformed by tech in the next decade. This isn't just about jobs going away. It's about how the very nature of work is going to change. How do we get people ready for that?
But with these massive challenges come, you guessed it, absolutely enormous opportunities. The smart money is already pouring into this field, and the predictions for growth are just mind-blowing.
This chart really shows you where the action is. Yeah, the robotics and AI markets on their own are growing fast, no doubt. But look at where they intersect. AI inside the VR and AR interface. That market is just exploding, projected to grow at over 46% a year. That right there is the rocket fuel for this entire revolution.
So for any company or any leader looking to get ahead of the curve, the playbook is becoming pretty clear. First, you have to invest in that low-latency infrastructure like Edge AI. Second, you need to treat synthetic data as a core strategic asset to train your AI faster than anyone else. And third, you have to focus on the human side. Build clear rules for accountability and invest big in reskilling your people using these very same VR tools.
So ultimately, what this all boils down to is something much bigger than just smarter software. This is the dawn of physically intelligent systems, a whole new kind of technology that's going to be woven into the very fabric of our world.
The technology is here, and it's moving faster than any of us could have imagined. So the only question that's really left is, are we ready for what happens next?